Hey there, hi there, ho there. Hey, welcome back. This is Unit 4 on tsunamis. Definite hazard associated with earthquakes, so kind of a logical progression of being the next unit. But tsunamis can also be triggered by other events. Earthquakes, though, are a common trigger. So let's jump into it, shall we? Now, the word tsunami actually is derived from a Japanese word, which means, or words, I guess, which means tsunami means harbor wave. So a giant wave coming into a harbor, an area where there's a lot of boats docked, and which is quite often the case. In any case, so what can trigger a tsunami? I already mentioned to one, earthquakes. Can you figure something else out that might trigger a tsunami? A giant wave rushing in on land? What might trigger such an event? Well, let's talk about it. So tsunamis are created by a sudden vertical displacement of water. Vertical, up and down. A vertical displacement of water, right? Think about if you've ever done a cannonball into a pool. As you are jumping into the pool, the water is, being pushed down and kind of rebounds back up. So we're talking about a vertical displacement, so this up and down motion. Not side by side, not side to side, not horizontal, a vertical displacement of water. So the water has to somehow get pushed up or down in order to create a tsunami. So what can trigger tsunamis are large earthquakes, landslides, volcanic eruptions, as well as impacts, large comets, asteroids, and these can produce mega tsunamis. This is just a list of some historic tsunamis. So this is, recorded history in some of the larger tsunamis. And if you look at the cause of these going back, over 200 years, so of these historic tsunamis, most are driven by earthquakes. You get a volcanic collapse, more on that in a little bit. But again, most tsunamis are going to be triggered by earthquakes, larger earthquakes. A couple to note. In 2004, the Sumatran earthquake in Indonesia, that earthquake was a 9.1 on the Richter scale, killed over 230,000 people. That's the deadliest tsunami in recorded history. So most deaths in this event actually occurred as that secondary hazard to an earthquake, the tsunami. Another one in 2011 in Japan, also 9.1, but yet that only killed 20,000 people. So this kind of goes back to thinking about, rich countries versus not so rich countries. What might be in place in Japan that, killed 210,000 less people? I mean, 20,000 people is still a lot. Don't get me wrong, but compared to 230,000, that's a big difference. It's a big difference. So tsunamis caused by earthquakes, we'll take each of those triggers and kind of break them down. It usually takes an earthquake of magnitude 7.5 or greater. Usually, all right? Usually. That doesn't mean that's always the case. Sometimes it could be a little less. Oftentimes it does require it to be a little bit more. It's more common that an earthquake around a magnitude 9.0 will generate a bigger tsunami. But usually around 7.5 magnitude on the Richter scale or greater. Usually. All right. The reason being you need a lot of vertical displacement of the seafloor, and that usually occurs around a 7.5 or greater. Usually. Not always, but usually. And typically, this is going to occur near a convergent boundary where you get something called a megathrust earthquake. More a little diagram on that in a minute. But again, it's this upward and downward displacement of water from the rebounding plates underneath to cause a tsunami. So it starts a 4-stage process. So when you get an earthquake, usually around 7.5 or above, near a convergent boundary, you create something called a megathrust earthquake that starts a 4-stage process of tsunamis. This 4-stage process is pretty similar for each trigger. Again, you just need to move some water vertically. So step 1 is there's some sort of rupture. So we see a fault down here. It looks like the hanging wall kind of thrust up. So that means it's a reverse fault. Very good. Compressional stress at a convergent boundary. So you get some breaking and pushing up, or sometimes as you get a plate subducting, that overlying plate will snap back and push all that water above it up. So you get this upward motion of the water. As the water kind of drops back down, it radiates out in all directions. If this occurs out in the deep ocean away from shore, you can get these tsunami waves moving at up to 900 kilometers per hour. That's 560 miles per hour. That's as fast as a jetliner. So if you're flying on a plane from A to B, it's about that fast. So it's just absolutely fast. As the tsunamis near land and the ground underneath the ocean starts to rise and the ocean gets more shallow, the water kind of slows down and stacks up. All right, imagine you're moving along on the highway and everyone in front of you hits the brakes and slows down. Well, then you're going to get a large pile up behind you. Kind of the same thing here. So because the ocean floor is rising, thus the ocean is getting shallower, so that water has nowhere else to go but kind of gets pushed up. And so it gets pushed up and kind of slows down and stacks up. So now by the time it's reaching shore, it's moving about 45 kilometers per hour, about 28 miles per hour. But it's much higher because it got stacked up. And then as it moves on land, it can travel in for many, many miles. So that's when you're talking about a megathrust earthquake, this is how the 4-stage process, which is very similar for all these other triggers. So landslides, kind of the same thing. So surface landslides, so if you have, imagine like a mountain right next to the ocean, material kind of just sloshes into the ocean, or a large body of water kind of pushes it down and it rebounds back up, radiating out in all directions. Or even underground, or I should say below the surface of the ocean, you do get landslides as well. So you do that, you kind of create a little vacuum, the water drops down. Vertical doesn't just mean up, vertical is up or down. So when the water gets pulled down, then it sloshes back up and then kind of radiates out in all directions. So it can happen from a landslide on the surface or actually submarine below the ocean. Again, you're displacing water vertically, causing a tsunami. Same process on the previous screen. One instant to note, again, is that a landslide can occur above the water or below the water. A great example of this would be in Lituya Bay, Alaska. Here, 30.5 million cubic meters of rock fell into the ocean, kind of slid right into the ocean. Let me just put that in reference. That's a lot of stuff. All right. The water in this little inlet bay, and I'll show you some images here in a moment, surged to over 524 meters. That's 1,720 feet above normal. So this initially created kind of a wave that kind of rushed up and over land at 1,720 feet high. So it's the highest kind of run up in history. Here's a number of different websites to check out to kind of look into this a little bit further, some YouTube videos to watch. But what you had here, so here's a glacier in the background. It's up in Alaska. So this purple area, there's a massive landslide, rock slide, and it just slid into this bay, and it caused this tsunami to go rush up and over and then out the bay to the open ocean. So just absolutely massive. Now the whole bay didn't rise that high. It's just that water got kind of pushed up and over. So a lot of run up. Just to show you how high that initial wave was, you can see that as the water kind of made it over that hill, over that mountain, it dropped in height. But initially, that's how high it got pushed up. It's crazy. For reference, this is One World Trade Center in New York City. You can actually see the site of the former Twin Towers in these memorials here. But this is the new largest building in New York and the U.S. One World Trade Center. For reference, this is a little almost 1,800 feet. So compared to what we have going on here, that's how big that wave was. It would almost go over the whole thing, including the antenna. So about up to here. I mean, this happened in New York City area, New York City would be gone. Maybe a little reference closer to home. What about the Phoenix Cardinals Stadium, State Farm Stadium? That's only about 200-ish feet high. So if you stacked 8 of those on top of one another, the tsunami wave was still higher than that. So that's only about 1,600 feet. And remember, this was 1,720. Mind-boggling. All right, so tsunamis can be huge. So here's some satellite image of the rock slide area, and you can see all the trees got scraped away. And then as that wave kind of made its way over, you can see about the height of it as it kind of continued out. Again, that wave height, 1,720 feet. You can see the scars, the trees removed from that wave as it radiated out of the bay. So this is where the actual landslide was, slid in. You can see this is the little bit of the hill that initially went up and over, but it's still a very massive tsunami as it kind of raced outwards. This shows you the damage area, the height above sea level that this reached. So again, the initial height of 1,720 and kind of dissipated as it got further out, but still about 25 feet at its smallest when it left the harbor. That's huge. 25 feet? That's still enormous. That's enough to destroy anything in its sight. So, earthquakes, landslides can cause tsunamis. What about volcanoes? So in a couple of different contexts. If, for instance, there's some volcano underwater and there's a heavy explosion, that explosion would heave water upwards, it would slosh back down outwards, creating a tsunami. Or kind of similar-ish to a landslide, sometimes when volcanoes erupt, some of its material will collapse and cause a landslide, sliding into the water, creating that vertical displacement, creating a tsunami. So that's actually pretty common as well. The second one's actually pretty common. And then you have tsunami created by impacts. And these could create something called mega tsunamis. So some high-speed impact, a comet or an asteroid, crashing into the ocean, creating a tsunami. Maybe you've seen Deep Impact. Here's a little clip that shows you kind of what that might look like. Yeah, I don't know about the accuracy as some of the other science in Deep Impact, but it kind of does. This video does give you a good visual of what a mega tsunami might look like if there was a large impact. For additional demonstrations on any of those types of triggers to cause tsunamis, whether it's earthquakes, landslides, volcanic sources, be it eruption below sea level or a landslide above, or major impacts, here's some great videos that show you the diagrams of how that might work out. All right, but the key here with a tsunami, you need to get some sort of vertical displacement, some sort of vertical movement to slosh the water up or down, and then it starts to radiate outwards. And these tsunamis can travel for thousands of miles throughout many oceans, depending on how big they are. So we'll pause here. So that's kind of how tsunamis are created. When we come back, we'll talk about some the areas around the world that are at risk from a tsunami hazard, damage, disaster, etc. So we'll pause here. I'll see you back in just a second.